Hi everyone, I'm Nir, and we're going to present observability for large language models with OpenTelemetry, which is something we've been working on for the past year. The CEO of Traceloop, which is a platform for LLM observability. Guang, you want to go ahead and present yourself?
This is Guang here. I'm from IBM and working for Instana, and I was mainly working in the area for cognitive observability and also open source integration for Instana. So I was mainly working for some open source products like the OpenTelemetry and some other open source products. Okay, so first I want to share two pictures. So if we go back to last year and from left part, we can see that many companies are trying to build models, like people are trying to build models like Llama model, and they are trying to build GPT model and IBM Granite model, etc. Yeah, so if we take a look at the right part, we will see that people are trying to build some apps on top of different models, like they're trying to build some chatbot, and they are trying to build some like translation tools, they are trying to build some propellers, etc. So we can see that for this year, people are trying to build some apps to help the customers. But the problem here is that how can they make sure that the AI can be trusted? So that's the major problem that we need to introduce AI observability here. So that's why we need AI observability. So basically what we need to do is that we need to provide trust the AI and transparent AI to the customers. So basically, if we want to enable trust the AI and transparent AI for the customers, we need to consider some errors as following. So the first one that we need to help the customer to evaluate the output of the AI response. Like we need to check if the response is correct or not, if it has any hallucination, etc. And also, if you are using some models in the cloud, and then you may want to know like how many tokens that have been used and what is the cost, etc. And also, sometimes if I run the model by itself, you may also want to check the latency of the models. Like, what is the latency of my model? If you have long latency for the models, and then maybe you need to improve the performance. And now we can see many customers are trying to build some agents. Like if you want to build an AI agent, and then you can have many different components, like it may have chains, it may have agents, it may have tools. So it's very complex app based on top different models. So we need AI observability to make sure that we can see the whole topology of the AI agent. And also we need to check the output and also the tracing for different components for AI agents. So that's why do we need AI observability here.
But I think before we dive deeper into why, like how to do the AI observability, I think maybe we should spend a couple of minutes of explaining, like refreshing to anyone, what is observability. And so commonly, when we think about observability, we think about three different ways to do observability. First one is logging, and I think this is the one people are most familiar with. Logging, as you probably know already, if you've ever written console.log or something on Python or any other language, is just arbitrary events that happen in your system. So if we're thinking about AI or LLM-based systems, then we're thinking about prompts, completion, function calls, images, etc. But if you've ever built any application, and you deployed it to production, you probably have already used logs. Metrics is the second thing. It's also pretty common to use. It's basically when you're looking at data points, you're aggregating over time, and then you're looking at things like latency or error rate. And again, if you're thinking about GenAI-based systems, we're thinking about token usage, and again, also latency, error rates, and etc. And then when you consume it in some observability platform, you'd see these graphs or some trends and pie charts, and etc. And the last type of way to do observability is tracing. And tracing is basically tracking of multi-step process. This is something that became really common when thinking about microservice systems. We have multiple microservices that communicate with each other, and then when you send a request to a system, then you're basically sending requests to one microservice, which follows another microservice. So you have like a multi-step process, and you probably want to track that process and then see what happens in each step of that process. This is tracing. And when thinking about AI, Gen AI-based systems, we have many times, even within a single service, we have a multi-step process. This is an example you can see on the right side of a RAG pipeline. So you have some embedding call, some query to a vector database, and then another call to an LLM to get a final result. So when thinking about observability, we also need to think about tracing. So this is all three of them: logging, metrics, and tracing. which together forms what is commonly known today as observability. And when thinking about existing observability tools for AI, we see I think two types of systems. One is the set of like open source projects, and that category have tools like OpenLLMetry and Trace that we're going to discuss today, and LangFuse and others as well. And we also have commercial tools like Instana from IBM, Dynatrace, Datadog, and many others, which also offer AI observability capabilities and tools for building generative AI-based applications. I'm going to spend a couple of minutes just briefly discussing Traceloop. Traceloop is a platform which is a company that I'm leading. It's a platform for AI observability and Gen AI observability. This is an example of what you can see specifically in Traceloop. This is a trace, as I said before. So when you're looking at complex systems, this is something you want to be looking at. You want to be able to view how a multi-step process works, what was the different latencies of different steps of the process, and being able to drill down to specific parts of the system. And then also being able to view metrics. So view, an example of the Gen AI, you want to view cost, you want to see which models you're using, you want to see token latencies, etc., etc. Wang, you want to kick it off for Instana?
Yeah, so from here you can see that this is some picture that I got from Instana. So basically I have 4 pictures here, so we can take a look at one by one. The first one that from here you can that we are able to use Instana to observe the metrics from different LLMs. But for the case, I think we are using Bedrock as a sample here. From here you can see that we can track the token that you have been used and the cost, and also some API requests that you have made, so that the customer have an overview of the metrics for their models. And another one that we can also have the customer to trace the logs about their apps. Like if you have a complex application, you may have some logs. So here we can leverage Instana to help you to monitor all the logs that's generated by your app. And this is the tracing. So from here you can see that if you have a complex app, and then we can leverage Instana to monitor all the steps in your trace. And also we can have you to monitor all the tags, like the metrics in each span here. So this means that with Instana, we can have the customer to collect metrics, tracing, and logging. In the meantime, Instana also has some feature like we can do some correlation about the logging, metrics, and tracing. This means that we can navigate the customer from logging to metrics, and we can also navigate the customer from metrics to tracing as well. And after you get all the data, and I think the major thing that you want to do is that you want to build some events, some alerts to tell you like what's happening in the cluster. Like if you are trying to monitor the tokens, if you are trying to monitor the cost, and then maybe you want to know like, does my tokens, does my cost exceed my budget? So you may want to configure some alerts, some events, and then events alerts will help you like if there are any events alerts have been generated, and then you will get notified. Like you can use Slack channel, you can use text message, or you can use some other pattern to help you to send the alerts to you. So that's the main feature about AI observability that can be provided by Instana platform. Yeah, so for this picture, actually, this is a vision like what will be the future of AI observability platform with OpenTelemetry. So from here, you can see that if we want to build an AI platform, and then we need to cover different layers, like we need to cover the infrastructure layer, like if you want to manage or if you want to run your own model, you may need some GPU resource. So with OpenLLMetry, with Instana, or with Traceloop, we have one of the GPU resource like the usage, the temperature, and some others. And another one is the vector DB. Like if you are going to make some RAG apps, if you want to manage your local PDF file, if you want to manage your other local files, and then you may want to have some vector DB to help you to persist your own data. Yeah, like you can leverage Python, you can leverage Read, you can leverage Chrome, etc. And for the LLM providers, actually we have different vendors. We have IBM OpenLLM platform, we have OpenAI, we have Hugging Face, we have Bedrock. So the customer can choose any platform that they want to use. And with OpenTelemetry, with instrumentation, we can have the customer to monitor any models that they're using. And now, and another thing I want to mention that, so now we can see many customers are trying to do some complex applications, like they wanted to build some agents. And then the agents will have many different components. It will have tools, it will have tasks, and then the tasks and tools need to call some API. So here we need to make sure that with OpenTelemetry, with AI observability, we should also make sure that we can also have the customer monitor the agents as well, so that the customer will have a overview like what's happening in my agent and what kind of action I need to take if the agent has any problem.
And I think the cool thing about OpenTelemetry is being able to standardize everything across the board. So on the left side, you have, as Guang has told you, you have a lot of things you can instrument and log and trace using OpenTelemetry. And on the right side, because OpenTelemetry is a standard protocol, you can send it to whatever backend platform you want. So the idea is that, you remember the logging traces and metrics that I've shown you, OpenTelemetry standardizes everything. So by using this standard protocol, you get standard way of observing your system, and then an easy way to connect it to any platform that supports OpenTelemetry. And right now, just so you know, probably the platform you're already using for observability is already supporting OpenTelemetry. There are more than 30 platforms, including the biggest names out there, that's supporting OpenTelemetry out of the box. So by adopting OpenTelemetry for AI observability, you're getting the flexibility to choose any platform that you want and even switch easily between them. One thing I want to mention as well is what you can see here. The centerpiece of OpenTelemetry is something that is called OpenTelemetry Collector, which is a way for you to do some pre-processing, post-processing for the data, the observability data that you send out from your system before it reaches, the backend, the platform that you're using for observability. And the way it works is that you can, by deploying this OpenTelemetry collector, which is a single container, you can configure it to consume multiple sources of, like, for example, for multiple services. You can configure it to process and maybe drop down or filter some data to reduce costs of observability. And you can also choose to export it to one or more systems pretty easily. It's just a YAML config at the end of the day. And I encourage you to go to this URL you can see here at the bottom, Hotel Bin, which is an easy way for you to explore what are the capabilities of the hotel collector and how can you pick and choose different configurations using OpenTelemetry. I want to spend a couple of minutes about OpenLLMetry. It's a new open source project to be around for a year. And the cool thing about it is that, we've taken OpenTelemetry, the OpenTelemetry technology for, that standardizes cloud observability, and we extended it to AI. And so we've built, on the left side, we've built ways to instrument and get logs, traces, and metrics from different providers. So OpenAI, Anthropic, Cohere, Light LLM, Hugging Face, Chroma, Pinecone, LangChain, Llama Index, you name it. There's like more than 40 providers supported by OpenLLMetry. So the idea is that you use OpenLLMetry, you get OpenTelemetry-based observability, which means basically that you can connect it to any of the platforms on the right side, because all of them support OpenTelemetry out of the box. And yeah, as I mentioned, there's like many providers supported, many vector databases, many frameworks, and you get basically those metrics, logs, and traces out of the box just by using those instrumentations. And I think the core part of the work we've been doing with the open source with OpenLLMetry is understanding how to do LLM observability. And if you think about it, the challenges of doing LLM observability are different than what traditionally we had with cloud observability. So thinking about those same metrics, logs, and traces, when extending them to LLMs or generative AI in general, you need to log and trace different things than what you would have done traditionally. For example, let's say you're using a vision model, you're using some model that can understand images. You probably want to see those images in the trace or in the logs. And this is something that never existed, in traditional cloud observability. You would never log images, you just log text. So now by providing these instrumentations, we had to tackle a lot of these challenges through the instrumentation. And one of the things we've been doing with the OpenTelemetry community, and I think this is one of the interesting projects for the next year, is standardizing the way to do observability for generative AI based applications. The idea is that we want to understand what are the different attributes, what are the different metrics that we want to see for generative AI systems, and want to standardize the way we do that. So, for example, even the name of the metrics that we report, we want this to be standard across board. We want, whether using Anthropic or OpenAI or any other model provider, we want to see the same metric for, let's say, latency or for token amount. So we expect this, to stay the same across models. This makes it easier for the other side, for the platforms to build visualizations that can, make it easy for you to actually observe your system. And so this is something we've been doing with the OpenTelemetry community. And you can even go after this talk to this link and see how we standardize, how we define the way to do generative AI observability. And so far, the work has been focused on two aspects. One is the semantic conventions. And so for the semantic conventions, we've been thinking about structure. So what should be the structure of the events we're sending for different types of requests and responses. What we have been thinking about attribute names. So exactly within logs, within traces, what are the attributes? And you can see some examples on the right side. How do we report, the model that was used? How do we report the server port, the server address, the number of tokens, et cetera, et cetera. And also metrics names. So for those metrics, for the graphs we want to build, we want to standardize metrics names across the board. And we've also been working on what we call official instrumentations. So like an official way of connecting to the OpenAI SDK, or an official way to connect to the Anthropic SDK, so that there will be like a central standard way to actually connect everything and see all the data that you need. That's it.